variables on both sides. Our only goal is to be able to say by the end of this, I can solve equations with variables on both sides. So, when solving equations with variables on both sides of the equals sign, we're only adding one concept more than when we solved two-step equations. We will continue to solve an equation for a variable. However, we must be aware that we can add and subtract terms. That's what we have here. We must be aware that we can add and subtract terms that contain variables as well. That's the only difference right here. Whoop, that was a terribly straight line. Okay, that's the only difference. We need to know that we can add and subtract numbers that are attached to variables as well. So once again, in number one, if we are to solve this equation, what's different about this than what you've seen all year so far is that you have variables, the same variable, on both sides of the equal sign. I don't know if I've said this many times this year, so I'm going to use this as a reminder. That equal sign is it's considered to be the middle of our equation. So I'm going to draw a line straight down the center. Doing that for a very specific reason. Okay, so our goal is to get all the x's onto one side and to get just a single x by itself. So in order to do that, we must somehow remove. So for instance, we could take this 2x and move it to the left side, or we could take this 5x and move it to the right side. I'd rather take the smaller one and get rid of it. So, just like before, you could add, subtract, and multiply or divide. As long as you did the same thing on the right side and the left side, the same thing is true here. If I subtract 2x from the right side, that's fine as long as I subtract 2x from the left side. Okay? So when I do that, let's see what we're left over with here. 5x minus 2x is 3x. And of course we still have our plus 12. And you should be asking yourself, what in the world do we have left on the other side? Well, 2x minus 2x is just 0. So right now we have 0 on the other side. If you notice, we do not have x all by itself, but what we do have is a two-step equation. So now, in order to get x by itself, the first step is to eliminate what's not attached to x. So let's subtract 12 from both sides. 12 minus 12 cancels out. So we have 3x left over here. And we have 0 minus 12, so we have negative 12 on the right side. Now, our last step should be obvious. You must divide by 3 on both sides. And I'm going to extend that a little bit further. So x must equal negative 12 divided by 3. X is negative 4. You should all be able to check your answer pretty easily. Let's go up here. Negative 4. What's 5 times negative 4? It's going to be negative 20 plus 12. That better be negative 8. Okay, and then 2 times negative 4 is negative 8. So it checks. Alright folks, the only new thing is that we have to remove the x's from one of the sides. We have to take them to the other side. I'm going to ask you to do 2 on your own. 2 is on your own, folks. Have that for me when you walk in tomorrow. Alright, on to number 3. Guess what? This is no different than what we did up above, except for now you see a few decimals. So don't be scared. It's no different. So once again, we have variables on both sides of the equation. So we need, before we can get a completely by itself, we have to have all of our a's on the same side. So I'm going to, once again, you can do it either way, but I'm going to take my smaller amount of a's and move them to the other side. So if I subtract 1a from both sides, remember my sides are determined by where my equal sign is. The equal sign is considered the middle of the equation. 1a minus 1a is 0, so that's just 1.7 left over on the left side, equals 3.8a minus 1a. So 3.8 minus 1 is 2.8a minus, and we still have minus 5.3 over here. Guess what? Now we have all the a's on one side. So what do we eliminate first before we can completely solve for a? Let's get rid of the thing that's not attached to the a. So in order to get rid of a negative 5.3, we must add 5.3. And you must do that on both sides. Let's get over this a little bit better. Plus negative 5.3 plus 5.3 is 0. That cancels out. So you have 2.8a. Don't miss that point right there. Whoa. Okay. Oh my goodness. Here's my pencil again. So 2.8a equals 5.3 plus 1.7 is 7.0, or just 7. Now the last step to get a by itself, this is 2.8 times a, is of course just to divide by a. Or excuse me, to divide by 2.8. Gotta do that on both sides. Here we go. So a better equal 3.5. I'm sorry. I was supposed to divide that by 2.8. I only divided it by 2. I almost made a mistake there. You guys all would have caught me, I'm sure. 7 divided by 2.8 is actually 2.5. Once again, you could easily plug that back in up here, check your answer. You should get the same thing on the left side as on the right side. Okay, number 4, pay close attention. This is real interesting, and it's definitely something I don't know that you guys have seen before. So, of course, the goal is always to get your y's, or you're supposed to get one y by itself when solving an equation. So what I've done in my first couple examples is gotten all the y's, all the variables, onto the same side. So let's try and do that here. So the simplest way to do that is just to say, all right, I'm going to add 6y to both sides. Remember, my sides are dictated by the equal sign. That's what determines the left and the right side. Negative 6y plus 6y is just 0. So I'm left with negative 3 on the left side. Equals, well, negative 6y plus 6y is 0. So all I'm left with is the positive 3. But what do you notice? Is this a true or a false statement? It's a false statement. Okay, so what this means, guys, is that normally we have one solution. Like over here we got 2.5. And up above on number 1 we got negative 4. Normally there's one solution to an equation. However, if you get to the point where you have a false statement, if you eliminate your variables and you have a false statement, the answer to this is that there are no solutions. There are no numbers. There's not a single number you could find that you could plug in for y, okay, in this equation on both sides, solve. You would never get the same number on the left as you would on the right. It's not possible. However, be very careful. Make sure that if you come down to this and you get like negative 3 equals 3 and you think, well, I've never seen that before, so that can't be right. Go back and do the exact same thing again. Make sure you did your work correctly. If you check it 2 or 3 times and you did get it correctly, then okay. If you have a false statement right here, that means there are no possible solutions. Hey, interestingly, if you had an equation and you did the same thing, let's say you eliminated your variables, just like we did here, but what happens is you ended up with a true statement, like negative 3 equals negative 3, well then it's just the opposite of no solutions. It is all real numbers, or all solutions. What that means is that you can take any number you can possibly think of, plug it in for y, and you will always, always, always get the same number on the left as you would on the right. But that's only when this statement right here is true. Once you've eliminated all the variables, if this is a true statement, then it will be all real numbers. Okay, we got one more example here. Number 5, a car rental agency has 2 plans. Under Plan A, a car rents for $80 plus $20 every day. Under Plan B, a car rents for $120 plus $15 a day. What number of days results in the same cost? Okay, folks, we're being asked to find. This is just like we're trying to write an equation for any given situation. We still have that 3-step process that you guys were given a couple days back. What are we trying to find, or what do we not know? And right now it is what number of days. So that's why I've let my variable represent the number of days that you rent for, because that's what we don't know, that's what we're looking for. Okay, Now that you have that, let's take that and use what else we're given to create some sort of an equation. Since we're given two plans, I separated this out and I kind of created two separate equations. Under plan A, a car rents for $80 no matter what. You rent it, you pay 80 bucks. Then you also pay $20 times every single day you rent it, since X represents the number of days. So if you rent it for 1 day, it's going to cost you $20 for that, plus $80, it'll be 100 bucks. If you rent it for 2 days, it'll be $20 times 2 is $40, plus your original $80, so it's going to be $120. That's how that works. Plan B, very similar, okay? Except for initially you pay $120, and then it's going to cost you $15 times however many days you keep it. Since we're being asked what number of days results in the, and this is the key word, once I can get my pen to work, same. What number of days results in the same cost? You're being asked how many days is it going to be that the price of this car under plan A is equal to the cost under plan B. So that's why we know that we're supposed to set those two things equal to each other. Once you solve for X, since X represents the number of days that you would have to rent for, that'll be our answer. What number of days results in the same cost? So folks, I am going to have you do this part on your own. Bring it back tomorrow. Hopefully you'll have the answer. Make sure you label your units at the end. Don't just give me a number. Tell me what that number means. And I'll see you tomorrow.